Okay, so we're going to start this video here looking at this next one. So there's my graph. It does get so repetitive. It cuts the x-axis on what? Y is 0. What I did there was a wee cheat. I swapped all the signs, so it's positive, positive, negative. Just because it equals 0, you can only do that when it equals 0. I factorised. I'll not go through all that. Let's do a factorise, but each bit equals 0. Or you can use your formula, whatever you want. Turning point, dy by dx, differentiate, put it equal to 0. Oh, this is good. I've only got one answer here. That's handy. Take your x, put it into your y. Work out your y coordinate. There you go. Don't forget your second derivative, under 0 maximum, and then just join the dots. It's always nice when it's a quadratic. Okay, what have we got going on in this one? Right, love these ones. Do you see the x in the bottom row? It comes up as a -2, just the x, then differentiate. So that's you. Okay, number 5, equation of a tangent. So hopefully you know what that means now. Writing that out. And you're told the point is 4 minus 56. Put in 4 minus 56. How do you work out your gradient? You take your y equation, you differentiate it, you put your x in. So it's 6. Multiply it all out and tidy it up. And then, do you see, now they were quite sneaky. They gave you y minus 6x equals 2. That really should be y equals 6x add 2. The gradient of this one is a 6. The gradient of this, remember y equals mx plus c? The gradient's number in front of the x, it's a 6. So the gradients are the same, which means the lines are parallel. Part 2. Find the now this is a nasty bit, to be fair. Find the coordinates of the other point, which is parallel. So basically they're saying, when else is the gradient equal to? What was the gradient dy by dx? So you see up here, put that equal to 6. Okay, it's a quadratic. Everything on one side. Divide everything by 3. Factorise. Each bit equals 0. Get your x's. And then you should know what we do now. You've got your x, work out your y. You've got your x, work out your y. That's the point they give you. That's the other point, which is why I put a box around it to show that's my final answer. Right. Next wee one. Verify the curve crosses the x-axis at the origin. That's a very fancy way of saying, where does it cross the x-axis? Put y equals 0. Put y equals 0. See we can factorise out your x to give you a quadratic. So x equals 0, and then this bit equals 0. It doesn't factorise, so I'm trying to use the formula. And look what happens when I use the formula. I get the square root of a negative number, which is impossible. So there's no solution. So basically it only hits the x-axis once. It's 0, 1. So we'll see what that looks like in the picture in a wee minute. The turning point. Remember how to do that? dy by dx equals 0. There's my dy by dx. Put it equal to 0. Factorise or use the formula. So I have factorised, but formula is fine. Each bit equal to 0, get your x's. Hope this is familiar to you now. You've got your x, work out your y. You've got your x, work out your y. There's your 2 points. Hopefully you know what's coming next. Second derivative. Put your x in, put your x in. 1 is a minimum, 1 is a maximum. Look, and there's your join the dots there. That point is 4/3, 4.15. And that was the maximum one, so it was going up and down. And the other one was 2, 4, minimum 1. And it went through the axis of 0. See the way it never hit the x-axis again? That was it, only at that one point. Okay, next one. Number 5 of 2013. We're going back in the years now. Right, find the gradient of the tangent. Now, it's not asking me for the tangent, it's just saying find the gradient of it. So do dy by dx, put in your point, x is -1. There's my gradient. I didn't have to find the equation, so I could finish there. Now let's see, part 2. I'm looking for the equation of a line, which is perpendicular. So y minus y1 equals -1 over m. That's the perpendicular bit, x minus x1. So my gradient is -5. So that will cancel down to a 5th. Put your point in, your x and your y, tidy up. Now, part 3. This is certainly a nasty wee question here. Find the other point on the curve that the line passes through. So take your curve and put it equal to your line. It's a quadratic, so everything goes on one side. So I'll have here 1x minus a fifth x, which is 0.8x, minus 4, add 1.8. Now, I wasn't going to try to factorise that. Well, you could if you wanted to. Pick out your A, your B, your C's, put it into your formula, and you've got your 2 answers. That's the one they had, and this is the other one. And the question, for once, was quite nice. It said, find the x coordinate. I don't have to go any further. I'm done. And we're on to the last question. Find the equation of a tangent. So there we go. And you're told the point is 1, 4. So put in your x and put in your y. How do you find the gradient? You differentiate, put your x in, and that's your gradient. So gradient is 10. Multiply it all out. Now, find the part 2. Find the coordinates of P, the point of intersection of this tangent and this line. Now you'll notice what I've done there. See, that's your line. I wrote it as y equals 26x add 18. So put them equal to each other. That's what intersection means. They're at the same place at the same time. X is one side, number's the other. You've got your x point. Once you've got your x point, you can put it into either equation because it's the same. You've got the same point to get the y. And that's you. And then the last wee bit's a funny wee one. Show that this point lies on this line. So that's a line. Take your point and put it in. So your y is minus 21. Take away 14. And your x is minus 3 over 2. And if you work out that, minus 21 is fine. Plus 21, that works out to be equals 0. It's true. So true, so point lies on line.